even after, when you're done with this, I want you to remember, I keep saying understand the material first. So diagram the pathways, write out the words, say them out loud, explain them to, your pet dog or whatever, the window pane. And then when you think you kind of understand what's going on, now go a little bit further, all right? And start interacting. I've got some review questions that I usually show at the beginning of our reproductive section, so let me open up. Remember our endocrine organ lecture in the past has come in, has come as the second lecture. So, if you write all these different words out on flashcards, and you put the definitions on the back, or the part of the pathway in which they're involved, don't just leave it at that. Now start integrating information between the pathways. So, which of the molecules are membrane bound? You've got this stack of flashcards. I put a few up there. Okay, the diacylglycerol is membrane bound, though 2 years ago it would have been listed as not. Receptors, I don't know why I have 2 receptors up there. So those are the only ones that are on there. But if you have the whole stack of different words, what other molecules have we talked about that are membrane bound? Adenylate cyclase, and it's semi-twin, paternal twin. Guanylate cyclase. Okay. What other enzyme do I not have up there? Phospholipase C. And there's another membrane-bound molecule. What's the molecule that phospholipase C works on? The alpha G protein. Yes, and our G proteins are membrane-bound. What's the molecule that the phospholipid molecule that phospholipase C works on? It's split the PIP2, phosphoinositol. All right.
That's membrane bound. I thought those.
It is one of the lipids. It's one of the phospholipids.
Oh, yeah.
Okay. Which of the molecules function as first messengers? What's our first messenger? The hormones. Exactly. Okay. So our hormones, or if we're still looking at the nervous system, our neurotransmitters are the first messengers. All right. Second messengers. Calcium calmodulin, cyclic AMP, its brother twin, cyclic GTP, GMP, sorry, you're right, come on. Diacylglycerol and IP3. Okay? So this is what I call lateral learning. Linear learning would be just one sequence of events after the other, and then you'd move to the next G protein pathway, and then you move to the next G protein pathway. But if you could explain similarities, all of these are similar functions, here it's where it's different, then you know that you have a thorough understanding of how that works. What molecule or molecules function to add phosphate groups? Protein kinase A, protein kinase C, one more. Well, the enzyme phosphorylase in that movie, yes. But I'm thinking of another one. What was our last pathway? The receptor itself. Remember, functions as a protein kinase. So even though it's not called protein kinase, it still functions to add phosphate groups. Okay, see how you're making your brain work? Not just recognizing the obvious, but aha, that's right. It was also, but it's not called protein kinase. What molecule or molecules inactivates a second messenger? The phosphodiesterase. So that's what I mean about going back, and now that okay, I understand this, start quizzing each other or asking yourself, okay, how can I look at this a different way? How can I pull out information between the different components to talk about where they're similar or where they're different? Okay, our last slide up for this activity brings us to the lipid molecules. It would also include, even though I have steroid hormones up there, on your lecture notes, you might want to add, it also includes our thyroid hormone. Remember, thyroxine is a lipid-soluble molecule. It needs a transport protein. It doesn't have a receptor in the membrane, but it needs a transport protein to get into the cell. And then its receptor is already in the cell. So steroid, any of our lipid hormones are, even though we're not going to spend much time talking about them in this unit, are icosanoids and thyroid hormone and steroids. Most of the hormones, I should put it that way. Many of the hormones we talk about for reproductive, obviously LH and FSH and GnRH are peptides, but testosterone, estrogen, progesterone are steroids. So when we get to those aspects, we'll be looking at them. Now, they are lipid soluble. As such, they pass through the plasma membrane. Either by diffusion or facilitated diffusion in the case of thyroid. And the receptor is going to be not on the cell membrane, but either one of two cases. The receptor is going to be located in the cytoplasm or in the nucleus. Okay. So that's not a V, that's a receptor. Hormone diffuses and binds to its receptor in the cytoplasm, or it may diffuse through the nuclear pores and bind to its receptor within the nucleus. If the receptor is in the cytoplasm, both of them, the receptor bound to its hormone, will end up diffusing and still end up in the nucleus. So it doesn't matter if the receptor starts out in the cytoplasm or starts out in the nucleus, the end result is the same. So what do we have present in the nucleus? Why are we sending these molecules to the nucleus? We have DNA, right? And DNA has codes for what type of organic material? Proteins. And so the role of the hormone-bound receptor is to activate new protein synthesis by causing translation to occur. So this molecule will bind to a segment of DNA. There's actually a restrictor protein that's involved, and it unlocks, and we start the whole uncoiling process and transcription and translation.